हेलो स्टूडेंट्स, लास्ट टर्न पर हमने प्रेशर के बारे में स्टडी की थी और उसमें हमने बताया था कि प्रेशर ऑफ फ्लूइड इज ए स्केलर क्वांटिटी बिकॉज इट एक्ट इन ऑल द डायरेक्शन एट एनी पॉइंट। हम किसी भी बॉडी को, जैसे हम किसी भी बॉल को यदि पानी के अंदर डालते हैं तो एट ईच एंड एवरी पॉइंट प्रेशर force will be perpendicular to the surface. That's why, because force perpendicular है तो बॉल के ऊपर सारी डायरेक्शन से इनसाइड में फोर्स लगेगा. That's why the pressure is scalar quantity, because pressure is force upon area. Now today we are going to discuss about the units of pressure. Units of pressure. First is, we know that pressure is equal to force upon area. Unit of force is Newton and unit of area is meter square. That is Newton per meter square. It is called Pascal. P, unit of pressure is Newton per meter square is equal to Pascal. In CGS system, it is equal to, unit of pressure will be, Newton की जगह हम CGS यूनिट ले लेंगे डाइन, एंड मीटर कन्वर्ट कर लेंगे सेंटीमीटर स्क्वायर. वी नो दैट 1 atmospheric pressure, 1 atm, it means atmospheric pressure equal to 760 mm of Hg. It is equal to 1.013 into 10 raised to the power 5 Pascal. It is approximately equal to 1 atmospheric pressure is approximately equal to, because 0.013 is very small, so we can say it is approximately equal to 10 raised to the power 5 Pascal, 180 m, and it is called 1 bar. It is third and it is fourth. 180 m, it means 1 atmospheric pressure is equal to 10 raised to the power 5 Pascal. It is also called 1 bar. The 1 atmospheric pressure equal to the 1 bar. Fifth unit is 1 torr. Torricelli is the scientist which he decided the unit of pressure 1 torr. 1 torr will be equal to 1 mm of Hg. We know that 760 mm of Hg is equal to 180 m is equal to 10 raised to the power 5 Pascal. That's why that is equal to 1 bar. So 1 mm of Hg is equal to 1 torr is equal to 1 by 760 into 10 raised to the power 5 Pascal, or we can say 1 by 760 bar. ऐसा भी हम लिख सकते हैं. Now some special points for the pressure. Pressure is a scalar quantity. We know that a ball is dipped inside the fluid, inside the water, force always perpendicular to each and every point of the ball. It means the pressure, the direction of pressure is not defined. That's why it is a scalar quantity. It is scalar because at one level inside the liquid, the pressure is exerted equally in all directions. Pressure is exerted equally in all the directions. Now, our next topic is pressure exerted by a liquid column. Pressure exerted by a liquid column. To express the pressure exerted by liquid column, we consider a tub which is full of water. Consider a liquid of density rho in a cylinder of cross-sectional area A. Let h be the height, or we can say the depth of liquid column, and g is the acceleration due to gravity. As per diagram, this is a cylindrical vessel filled with liquid. Its cross-sectional area, it is equal to, cross-sectional area is A, and height of liquid column, इसमें जो लिक्विड भरा है उसका एक कॉलम बनेगा, एक तरीके से सिलेंड्रिकल शेप का एक कॉलम बनेगा. उसकी जो हाइट है दैट इज इक्वल टू द h as shown in figure, and rho is the density. Then we know that volume of water or liquid, volume of liquid V is equal to area of cross section into h. We know that mass of liquid column, जो लिक्विड पूरा भरा हुआ है उसका मास कितना होगा, दैट इज m इज इक्वल टू वॉल्यूम इनटू डेंसिटी. So that mass will be equal to V into rho, that will be equal to AH rho. Now weight of the liquid column, W is equal to mg. Weight of the liquid column, W is equal to mg. That is equal to, for the value of m, that is A, H, rho and g. It is the weight of the liquid column, and we know that weight of the body, weight of the liquid column, any weight will be equal to the force applied by the earth towards its center. So weight is the force, weight is known as a force. Weight equal to the force by which the liquid attracted towards the center of the earth. It means weight always be equal to the force. So we know that the pressure, कि फोर्स कहाँ लग रहा है, इट इज ऑन द बॉटम, बिकॉज h जो हाइट है वो बॉटम के लिए हम कंसिडर किया हुआ है, जो वाटर कॉलम की हाइट है दैट इज h, तो जो वाटर का टोटल वेट है उसकी वजह से जो फोर्स लग रहा है इट इज ऑन द surface of the cylinder, and it is equal to force is equal to pressure equal to force upon area. So force is wet A, force is A H rho g upon area, means area of cross section, that is equal to A, and here cross A by A. Now pressure is equal to H rho g. It means pressure of the liquid column on the bottom of the cylinder always equal to rho hg, because here rho is the density of liquid, it is constant, g is gravitational acceleration, it is also constant. It means pressure depends on the height of the liquid column, pressure directly proportional to height of the liquid column. You can say if H is greater then pressure is greater. The liquid at rest exerts equal pressure in all direction at a point inside the liquid. हम कहें कि जो प्रेशर इसके सिलेंडर के बॉटम पे लग रहा है दैट इज equal in all the direction. With the help of this formula we can calculate the atmospheric pressure. We know that atmospheric pressure, that is 180 m is equal to 760 mm of Hg, or P is equal to H rho g. Here H is given 760 mm to be converted into the meter. It is equal to 1000 meter, that is 0.760 meter. So put the value of P is equal to H is 0.760 into rho, density of mercury, Hg, density of mercury is 13.6 into 10 raised to the power 3, and G is 9.8. It is equal to 1.013 into 10 raised to the power 5 Newton per meter square, that is equal to Pascal, and P is equal to 1.013 into 10 raised to the power 5 Pascal. We can calculate the atmospheric pressure in terms of SI system. Pascal is the unit of pressure.
Some important points about the pressure. First point is the liquid at rest exerts equal pressure in all the direction at a point inside the liquid. Exerts equal pressure in at any point. Second point is the liquid at rest exerts equal pressure at all those points which are in one level. Pressure remains equal at equal level, और at one level हम बोल सकते हैं. किसी एक लेवल पर प्रेशर इक्वल रहता है एट इक्वल एट वन लेवल. जैसे हम बोलें कि किसी भी सिलेंडर के बॉटम पे जो प्रेशर है, बॉटम का लेवल सेम है और उसके ऊपर जो लिक्विड कॉलम है वो उसकी हाइट इक्वल है, तो हम बोलेंगे कि प्रेशर एट ईच एंड एवरी पॉइंट ऑफ द बॉटम ऑफ द सिलेंडर रिमेन्स द सेम, रिमेन्स द इक्वल. थर्ड पॉइंट इज pressure is independent
shape of the liquid. It depends only the height. The next point, fourth point, is the total pressure at a depth h. The total pressure at a depth h will be equal to the P0 is atmospheric pressure plus H rho g. H rho g is the pressure due to the water column or liquid column, and P0 is atmospheric pressure, where P0 is atmospheric pressure. The mean pressure on the wall of a beaker will be equal to 1 by 2 H rho g. That's all.